Hi guys, I'm Hero Serrano and I developed the Untold engine. And in this video, which is going to be the first one related to game engine architecture, I want to talk about the game engine loop. I want to talk about the purpose of the loop and how it makes a game possible. So let's begin. Basically, as I have mentioned in my blog and in previous answers that I have given on the Quora, a game engine is composed of four major components. They are the mathematics engine, the rendering engine, the collision detection, the physics engine, and the collision detection system. And these all of these components make a game engine uh, possible to uh, create a game character, to render a game character on your screen and to create the illusion of gravity and the illusion of collision. And how all of these components work together is through a game engine loop. And it is what I have right here. A game engine loop basically makes all of the components of the game engine work together in and in sync. For example, let's say that we have an entity that we want to render. During the game tech, a game engine loop will grab we'll grab an entity from the entity manager, and it will send that entity to the rendering engine where it will be rendered, and then the entity will go to the physics engine where it will be affected by external forces such as gravity, and after that, the entity will go to the collision detection, which will basically detect if the entity is colliding with another object, and finally it will go into the update method. And then during the second game take, the whole process repeats over and over again, and this is what basically powers a game. It's the game engine loop, which is what calls all of the components of a game engine. However, what I have right here is only for one entity, right? And a game has multiple characters, multiple games, multiple game assets. So, in reality, a game engine loop looks more like this. All of the entities are stored in data structure called a scene graph. And a scene graph is basically a data structure that is very efficient when it comes to game engines, because it allows the game engine loop to traverse through every game entity very efficiently, and thus prevent any bottlenecks whenever the game engine loop is retrieving a character. So how it works is like this. During a game tick, the entity manager traverses the scene graph, and for every entity, it sends that entity to the rendering engine where it is rendered, as I mentioned before, and then it goes to the physics engine where where the final velocity and final position is calculated, and then it goes to the collision detection system, and then it goes to the update method, and then the whole cycle repeats. During the second game tick, again, the entity manager traverses through the whole scene graph again, and for every entity in the scene graph, the entity manager will force that entity to go through the different components. Now, before I keep on talking about the game engine loop, when I think about game engine loop and how I was able to understand it better as I was developing the game engine, is to think of the game engine loop as the back end um, of a game engine. Um, the front end is basically where a game developer would create an object, and where the game developer would actually implement any code to determine what should the the character do if there was an user input from a gamepad, right? And a good way to understand the back end and the front end is to think of it like this. The back end, which is what I'm highlighting here, is basically the game engine loop, and then the scene graph, right? A game developer doesn't really touch this section of a game engine. Or what he really touches is the front end. And the front end is basically composed of a design pattern called the model view controller. I'm sure you have heard about this design pattern many times. And just to recap, the model view controller is composed of three components. They are the controller, which basically deals with the external user inputs coming in from a mouse, from a keyboard, from a gamepad. Then we also have the model component, and the model component basically is the logic of your game. It's basically the decisions that it is made if something happens within a game. And then we have the view component, and the view component is basically what you see. It's the screen of your iOS device, of your computer, whatever. Now, this is very important to understand because it is through the model view controller where you actually create a character, where you actually control a character, where you detect the user inputs of a controller. And if you notice, the only way to access the scene graph is through the view component. So what this means is that when you're about to code, you create a character in the view component, and then you add it to the scene graph. And once it is added to the scene graph, then the game engine loop takes over it and will render it. It will send it to the physics engine, collision detection, update, and on again. So basically, this is a general view of a game engine of a game engine architecture. We have on the front end, we have the model view controller, which is where the game developer spends most of his or her time, and then on the back end we have the game engine loop. And the one thing that you need to keep in mind is that it is through the view component that we create a character, and where we can actually add it to the scene graph. That's the key. All right. Now, why don't we do an actual example using the Untold engine? So that way you have a better idea of how everything works. All right. So why don't we do this? We are going to create a character in the view component, and then we're going to add it to the scene graph, and then we are going to see step by step how each of these components affect the character. All right. So we're going to start out by just doing a simple rendering. And before we do that and start using the Untold engine, what I want to talk about is how do you actually create a character. So let's talk about that for few minutes before we move on. So I have here the process to create an entity, a 3D entity in this case. So everything starts out like this. The first thing that you need to do is you need to create an entity object. And this entity object is basically memory allocated so that you can store the attributes of a character and the properties and behaviors. Basically, you are creating an instance of a class, an object. That's what you are creating. You are allocating memory for that object. Once that instance has been created, the next step is to actually load this section of memory, which is designated to be a section for the attributes. We need to load this section of memory with the actual data from a character. Okay, and the data that we need from the character are known as vertices, the normal vectors, and the UV coordinates. And all of these three elements, they are known as attributes. And you may be wondering, well, what in the world are these? What is this? What is a normal vector, UV coordinates, etc.? So let me explain it really quick. Basically, a 3D game character has three set of data that a game engine needs in order to properly render it. It needs the vertices of the character, and the vertices basically are just the points that makes up the geometry of the character. And the GPU uses the vertices of the character basically to recreate the geometry on the screen of your iPhone, on your computer, etc. Then the second element that a game engine needs is the normal vector. And the normal vector, if you notice, is basically a vector perpendicular to the vertex. And if you notice here, if you notice the space coordinate of the vertex, the normal vector is actually perpendicular to that space coordinate. You can see how both of these space coordinates are actually perpendicular to each other. And the normal vector is used to apply lighting and shading effects on the character. And the third element that a game engine needs is actually the UV coordinates. And we use this set of data to basically apply an image to a 3D character. Think of it this way. This character is in 3D space. In order to apply a 2D image to it, we need to unwrap this character from 3D space onto a 2D space, which is what is shown here. And once we have it in 2D space, then we can apply an image to it. And basically, these are the three elements that a game engine needs to render a character, and they are known as attributes. So let's go back here. So once we read the attributes, we load the attributes into this section of memory in the object. And then the third step is that we need to send these attributes to the GPU, which the GPU will eventually use it to render the character. All right. And the final step, once we have everything set, is we need to add this game object to the scene graph. And once it is in the scene graph, well, the game engine loop will traverse the scene graph and will render the character as I explained earlier. Alright, so now you may be wondering, how do we read the attributes of a character? How do we get this data? We know what they are, but how do we actually read it from the modeling software that our game artists may use to develop our character? Well, that's what I'm going to talk about next, right, in this section. What I have here is a screenshot of Blender, and Blender is basically a 3D modeling software that game artists use to develop game characters, to design game characters. And what we need from this set of characters that we have on the screen right now is we need to read the attributes. And to do that, we use a script which is known as which I call a digital asset exporter, which will basically go through every of the characters in the scene and provide all the attributes, vertices, normal vectors, and UV coordinates onto an XML file, which we will later use. Now, the Untold engine has this script which I wrote in Python, and I call it again digital asset exporter, and the whole purpose of it is to read the attributes and put it into the XML file. So now how everything really looks in more detail is that we create the entity object, right? Now when we load the attributes, what we do is we basically read the XML file using a digital asset loader. In the digital asset loader, we'll basically dump the data into the attributes buffer section. Then we send it to the GPU, and then we send it to the scene graph, and everything goes on. And how do we do this in code? Well, it's actually very easy to do this using the Untold engine. Our first step, as I mentioned, is we need to create an object, and we do this by using the parent class U4D GameObject. And here I am showing you how you actually create the character. U4D GameObject, you give it a name to the pointer, and then you use new and U4D GameObject. And here we are actually creating the entity. Next, the second step is basically to load the attributes, and in this case we use the method load model, and the method requires two parameters. It requires the name of the character that we want to read the attributes of, and it requires the file, the XML file where you can find that information. Then the third step is we need to send the data to the GPU, and we use the method load rendering information. And finally, we add it to the scene graph using the method add child. So now let's do some coding. So that way you can actually see how everything works. I'm gonna bring up, hold on, I forgot something to explain. I'm sorry, but I need to explain this because else everything will get confusing. So remember when I told you that the only way that we can access the scene graph is actually through the view component? Well, we need to know how does the Untold engine implements these components. And how it does it is that the view component is implemented through a class known as a U4D world class. The controller is implemented through a class known as U4D game controller interface, and the model component is implemented through the U4D game model. And When you download the engine for the first time, what I provided, so to make it easier for you to use, is I created subclasses that inherit the behaviors of each of these components. Uh, for example, the game logic subclass inherits the behavior of the U4D game model. Then the Earth class is basically a subclass of the U4D world class, which is a view component. And for the for the controllers, I actually the control. If you see here, the controller is actually an interface. So what I do here, I actually have several subclasses that will get enabled depending what is attached to your device. For example, the game controller subclass will be enabled if you're using an iOS device, a gamepad if you are using a gamepad, a keyboard controller if you are just want to play using your keyboard, and on and on. So when you open up the engine for the first time, you will notice that there is a folder here called a game folder, and here we have our view component, which is the Earth class. Then here we have our game logic, which is our model component, and for our controller component we have the game controller, gamepad controller, and the keyboard controller. So keep that in mind. All right, so let's do some coding now. Like I said, we are going to create our game entity using this set of methods. All right. So let's keep this here. So number one, I'm in the Earth component, which is the view component basically, and I want to create an object in the init method. All right, so my first step is to basically create a U4D game object, and then I want to load the attributes, and I need to send the info to the GPU, and then finally I need to add it to the scene graph. So let's do that. My first step is to create my astronaut, and I'm going to do the following: my astronaut new U4D engine U4D game object. And by the way, if you're wondering, I declare this pointer here in the header file as a game U4D game object. So that's why I'm not declaring it again. I'm just defining it. Now, my second step, once I have created the object, is I need to load the attributes. And to do that, I'm going to put everything in within an if statement, because the method load model will return true if it was able to read and load the data, and it will return false if there was a corruption in the file. Alright, so now, like I mentioned earlier, the method load model requires two parameters. The first one is the name of the model, and the second one is the name of the file. Now, if you go to the resource folder, all of that data is actually in this file called astronaut attributes.u4d. And then if you open it, you will actually see all of the data, and here shows the name of the astronaut. that we want to render. So we're going to provide that. Astronaut, and then the name of the file, which is astronaut attributes that u4d, and then we close that. Now if the method returns true, then we want to send the data to the GPU, and we do that by calling the method load rendering information. And finally, we add it to the scene graph. So we do add child and provide the name of the pointer. And there you have it. Now, if we build this, it should build successfully. And there you go, it was built successful. Now let's run it. So now you see here how the Untold engine render the character. Basically, as I mentioned earlier, the game engine loop is actually doing all the work by sending the object to the rendering engine. Okay, so now that we saw how to create an entity and load it into the scene graph, right now we saw how the engine loop is actually rendering the character. Our next step is we actually wanted to send it to the physics engine so we can see how the physics engine affects the character by applying simulated forces. Now, by default, when you enable the physics engine, gravity is turned on. So what's going to happen is that when we enable the physics engine, the character will actually start to fall because gravity will be pulling it downwards. Alright, so expect to see that when we run the engine again. But before that, what we need to do, we need to enable the physics engine. And to do that, it's actually very simple. To have the physics engine simulate external forces, what we need to do is we need to enable the kinetic behavior on the character. So let's do that. Let me bring up Xcode, and what I'm going to do here is I'm going to enable kinetics behavior. So I'm going to do my astronaut enable kinetics behavior, and that should do it. However, what I'm going to do so you can actually see it fall is I want to move the character up a little bit because what's going to happen when I run it, the engine will fall and it will go through the floating island that you saw in the previous example. So what I'm going to do right now is I'm just going to translate it by a couple of units upwards, by 2 units. And that is it. So let's build this and let's run it. So now, as I told you, gravity is pushing the character downwards, and as you saw, the character went through the floating island. So what we're going to do now is we're actually going to enable collision detection, so the character will actually collide with the floating island. All right. So now, to enable collision detection, again, it's very simple. All what we need to do is we need to enable the collision behavior of the character, and we do that by again using the method enable collision behavior. So let's do that. We are going to enable collision detection. And we do that by using my astronaut enabled collision behavior. And now when we run it, you're going to see that it's going to collide with the floating island. And there you have it. You saw how the character actually collides with the floating island. Alright, so now what you have seen is basically the game engine loop in action, right? You saw how it was how it rendered a character, how physics engine affected the character by making it fall due to gravity. You also saw the collision detection, and the update method is basically where you change the state of a character. I'm not going to do that in this video. I'm going to do that in other videos because it's actually quite simple. It is where you actually change the state of a character. For example, let's say that your character was walking and you change the state to shooting. This is where you will do such change, among other things. But what I want to do here also in this video is actually show you how the controller can sense an user input and modify the position of a character. All right, and again, all of this happens in the model view controller pattern, right? So what we're going to do is I'm going to eventually use my gamepad to move the character along the x-axis. All right, so let me explain to you how that works, and so we can do a simple example. All right, so let me bring this up. Before we do some coding, we need to understand the interaction between the model view and the controller components, which is very interesting actually, because each of these components can actually communicate among each other, but none of them know about the other component. Basically, when you design a model view controller, one of the requirements is that they must be decoupled from each other, which means they can communicate, they can send data, but they have no idea how the other works. They do not depend on each other to do their work. They just work independently, and when it is required, they communicate. Besides that, there's no a strong linkage between them. All right, so let me talk a little bit about the controller and the model interaction first. What happens between the controller and the model is that whenever there is an user input detected by the controller will alert the model through a method called receive user input update. And when it alerts the model, the controller basically sends a packet of data that contains information about the particular button or joystick that was moved or pressed, and that data is sent to the model. And then at this point, the model does whatever it needs to do with that data. It can either translate a character, it can do whatever it needs to do. It's basically up to the game developer at this point. Then the second interaction that occurs is between the view and the model components. And one of the interactions that usually happens is that the model obviously does not know anything about the scene graph. It has no idea about these characters. So one communication that occurs is that the model will actually ask the view component for a particular entity through a search. Basically, the model says, "Hey, I need to search your scene graph. Can you give me this pointer to this character?" And the model view goes into the scene graph, search for the character, and it will return the pointer of the character back to the model. And once the pointer has the pointers to the character, the model can actually do something with it. In this case, it can translate the character, or it can rotate the character, or it can animate the character, whatever it needs to do. And basically, that's the major interactions between these components. Okay, so what we're going to do here is, again, what we want to do is we want to detect a user input, and we want to translate the character. But to do that, what we need to do first is we need to go into the model component, and we need to get a pointer to one of our characters in the scene graph. And we do that by doing a search on the scene graph and asking that from the view component. Once we have that pointer, then we simply translate the character. All right, so just so we know, one way to search the scene graph is basically, number one is to get a pointer to the view component, right? And this is how we basically will get a pointer to the view component using the method getGameWorld. And once we have the pointer to the view component, then we can do a search of the scene graph and get a pointer to the character. So to do that, we basically do a search child and then provide the name of the character that we want to search. And this method will provide a pointer to our character. And at that point, the model can basically do whatever it needs to do. All right, so let's do that in code. We are going to go into the game logic, which is again the model component, and we are going to search for the character in the init method. So first of all, we need to get a pointer to the view component, and then we are going to get a pointer to our character. All right, so one way to get a pointer to the view component is to do the following. We need to use a dynamic cast because the method that we're going to use, which is getGameWorld, actually it returns a pointer of u for the entity type, and what we need to do, we need to cast it to be u for the world type, which is the view component, in this case earth class. Once we have the pointer to our view component, then we can actually use the search child method to get a pointer to our character. And before I keep on going, I want to let you know that I have declared the pointer pAstronaut as u for the game object here in the header file. All right, so now we're gonna do pAstronaut, and again we're going to use a dynamic cast because the search child method returns a u for the entity type GameObject. And now we're going to do p-earth and search child, and here we need to provide basically the name of the character that we're looking for. In this case, the name is astronaut. All right, now like I mentioned before, The controller alerts the model component of any user inputs in the receive user input update method, which is here. And this method basically receives a whole packet of data from the controller, and the switch statement that I have here basically parses all of that information. In this case, if you see this section, I'm saying, okay, is the input type, did it come from button A? If it was from button A, was it pressed or was it released? The second case here is, okay, did the user input came from button B? And again, we select, we test, was it pressed or released? Here we do a test on the joystick, etc. But what we're gonna do here is basically whenever I press the key A on my Mac, I want my character to move to the right along the positive x-axis, and whenever I press the key D, I want the character to move to the left along the negative x-axis. So let's do that. We have the pointer here to our astronaut, so it's going to be astronaut translate by, I want to translate it by 1 unit, and if key D is pressed, then what I want to do, I want to translate it to the left. Translate by. And that should do it. So let's build this. Actually, before I run it, what I'm going to do here, I'm going to remove the enable kinetic behavior and the collision behavior, because I don't want the character to be falling and to be colliding. I just want it to stay there on the screen, so you can actually see me moving the character through my keyboard. All right, so I'm just going to remove this, and I'm going to build it again, and then I'm going to run it so you can actually see it. All right, so what I'm going to do here, I'm going to press the key A on my keyboard, and the character should move to the right along the positive x-axis. There you see it. Now I'm going to move the key D, and the character should move to the left along the negative x-axis. And there you have it. Cool. Now what I'm going to do next is that instead of using the keyboard, I'm actually going to use my game controller, my gamepad controller. And whenever I press the key A, I want the character to move to the right, and whenever I press the key B, I want it to move to the left. The cool thing is that there's really not much change in code that you have to make. You only have to enable one method, and that will basically detect the controller, and it will allow you to control the character through the game controller. So let's do that. Alright, so to allow the game controller, the gamepad controller, to actually detect the character, what we need to do, we need to go into this folder called Untold for the Mac OS, and basically I'm going to set this method called set gamepad controller present from false to true. Basically, I'm telling the engine, hey, there is a gamepad controller, so detect it. Now I'm going to turn it on. And once it is on, I'm going to go to my Bluetooth section and make sure that it is connected, and it is connected. All right, so now I'm going to build this, and we should see the controller moving the character. All right, so now whenever I press the key A, we should see the character move, and there you have it. And now when I press the button B, it should move to the left, and there you have it. Cool, huh? All right. Okay, so to recap, a game engine is composed of four major components. They are the mathematics engine, the physics engine, the rendering engine, and the collision detection system. And it is the game engine loop that makes all of these components work together. Um, and as you saw here, the game engine loop will traverse each entity in a scene graph, and it will send that entity to the rendering engine, and then it will send it to the physics engine, then collision detection, and then the update. And this process repeats all throughout your game. Furthermore, um, the entities are provided to the game engine loop through the view component of the model view controller. This is where we actually create an entity and where we add it to the scene graph. In the same token, it is here in the model view controller where we actually detect a user input and inform the model component of a user input and let the model component basically decide what to do with that input, either to move a character, to translate the character, etc. And that's basically a general overview of a game engine architecture. We have the front end, which is where a game developer spends most of his time in designing his game, and then we have the back end, where we have the game engine loop and where all of the components of the engine basically come together and work together to render a character, etc. I hope that this video helped you understand a little bit more about game engine architecture. I'm going to keep doing more videos like this throughout this whole year. Don't forget to subscribe to my YouTube channel and to my Twitch channel. So thank you, and we'll see you next time.